Hello and welcome to week 4. In this lecture, we will introduce the analyze phase of the make process. In this phase, we will analyze the data that we had previously gathered with a view to understanding the cause and effect relationships and sources of variation in our process.
The third step of the make process is known as the analyze phase. In this phase, we will analyze the data that we have previously gathered in the measure phase with a view to understanding the cause and effect relationships and sources of variation in our process. We will apply statistical and graphical analysis techniques to determine the potential causes of defects and problems in our process. There are a number of techniques that we will apply, such as cause and effect diagrams, histograms, multivariate charts, and scatter diagrams. The outcome of this phase is to provide us with ideas, potential solutions, and opportunities that we can then explore further. If we take an overview of this phase, what we're going to do is we're going to apply statistical and qualitative techniques to formulate hypotheses regarding root causes of the problem. We're going to look for patterns in this data and then identify the sources of variation that might identify sources of variation. And then finally, we're going to identify the significant causes that we can then focus on in the improve phase. There are a number of tools in the analyze phase, and we're going to take some examples of these. There are some statistical tools that we can apply, such as histograms, scatter diagrams, and multivariate charts. There are also qualitative tools, such as cause and effect diagrams. The emphasis on all of these tools is to help us to analyze where the sources of variation are in our process. If we take the example of our pen holder once again, the critical to quality characteristic was the inner diameter. Here we see a number of inner diameters associated with this pen holder. And we can see here the measurement of the inner diameter taking place. If we gather these inner diameter measurements, and we see here the first one is 30.727 millimeters, and if we measure all these and list them in a list format, it's extremely difficult to identify what is occurring in our process. We cannot see where does the center of this data lie, how spread out this data is, or even where the maximum and minimum of this data may lie. The shape of this distribution of this data is also unknown. We can use histograms to help us to identify all these characteristics of the data. The histograms will allow us to visualize data that is difficult to interpret and to help us to observe patterns in data. We create histograms by drawing a bar chart of the raw data, and the bars on the histogram represents the frequency of occurrence by category, class, or dimension. The histogram shows us basic information such as where the center lies, the shape of the data, and also variation of this data. Here's an example of a histogram. We see that the frequency associated with the bars, we see that the center lies around 30 millimeters of the inner diameters. Okay. We actually see the spread, and we actually see the overall shape. We see where the maximum lies and where the minimum lies. So this gives us an overall view of the data, something which we cannot gain by just looking at the raw data itself. We can draw an overall shape of that, and we see that the overall shape is given as a normal distribution or bell-shaped curve. And we can see that it complies reasonably well with the bell shape or normal distribution. We can also, on a histogram, mark off the upper specification limit, which in this case is 33 millimeters, or the lower specification limit, which is 27 millimeters, and we can see where the data lies in relation to these dimensions. Is the data centered on the nominal of the specification? Is the data capable, is the process capable of meeting these specifications? Strengths of the histogram lie in the fact that it's a visual approach to analyzing the data. It's simple to perform, and it's very, very powerful. There are numerous statistical packages available which will allow us to draw histograms very, very easily. We can quickly summarize large amounts of data with this histogram, and it can show relationships between the characteristics variation and also the specification, and from that we can visually assess whether the process is capable or not, and it can also identify such statistics as where the center lies, where the mean, the mode and the median. In this case we see the normal distribution, and we see the specifications, but not all the data that we will plot will actually follow this normal distribution, and we can actually study this pattern to provide clues as to what the root causes of the problem and where the difficulties may lie. We will now present some common patterns which will indicate potential or probable causes associated with the data. Here are some examples of histograms which do not follow the normal shape. In the first example, we see that the data is skewed towards the left-hand side. So we have more data items towards the lower end than we have towards the upper end, and presenting it with this non-normal shape. Now this may have occurred because the items at the upper end of the spec may have been removed because they fell outside specification. Similarly, we could have data which is right skewed, or a histogram which is right skewed. This may have occurred because data which should have been presented in here, our items, has been removed because it was below the lower specification. And this may tell us, when we see this data, what could actually be happening in our process. There are other shapes which are possible. Here we see examples of what would appear to be normally distributed, but we do not have any data in the tails. So there's no tapering in the tails. And this could have arisen because parts which did not meet the specification were simply removed, and we were presented with data with items which just met the specification. We could also have a bimodal distribution. This may occur because it could be the output from two different machines or the output from two different shifts, and this may tell us what could be happening in our process. Maybe one machine is operating towards the upper end of the specification, or the other machine may be operating towards the lower end of the specification. There could also be a situation of long tails in our process, where we expected few items to fall in the tails, but in actual fact we see larger than expected volumes falling within the tails. This might have occurred because items which had fallen outside of the tails, or which were towards the extreme upper end, or even outside spec, or towards the extreme lower end of the spec being outside, were actually reworked in order to bring them within specification. There's also possibilities we may have data, the center missing from the data that we're presented with. This could be because we were presented with items that had the centers removed. For example, the supplier may have been removing these parts because a customer wanted a tighter tolerance specification on certain parts, and all these were removed and submitted to that particular customer, and we were left with what was in the upper tails and the lower tails. The histogram is a very, very useful technique to actually apply. However, it does have certain weaknesses. We do not have the ability to assess whether the process is stable over time. For example, our process may actually be shifting, and we will not know this by simply viewing a histogram, because time is not represented, and this is a major disadvantage to histograms. It will take quite a large amount of data to present it on histogram before we actually see a pattern or a distribution. If we look for a small sample, maybe 20 items, and do we see a distinctive normal shape, we'd be extremely unlikely to see that with just 20 samples of data. Also, the shape can be subjective. What might appear normal to one person may not appear normal to another. This concludes part A of the Six Sigma, the make analyze phase. We will also, in the next section, look at part B, where we will introduce scatter diagrams and multivariate charts. Thank you.